Every circle will be having its own center. The center of the circle is one of the things you know very clearly. Another thing you have studied about circle is about its radius, about its diameter, and about chord. As far as radius is concerned, it is the distance from the center to the circle. In this case, you can read it as 4.7 centimeter. Even if you draw another radius, that also will be 4.7 centimeter. Another thing you studied is about the chord. Chord is different from radius because chord will be touching any 2 points on the circle. This is a chord. This is a chord. Radius is not a chord. But if there is a chord passing through the center of the circle, let me draw it. Let me take another color for it so that it can be seen distinctly. Suppose that there is a chord passing through the center of the circle. Like this. This is also a chord passing through the center of the circle, having 9.4 centimeter according to this particular measurement. 2-3 things comes into our mind. One is that this is a chord. As it goes through the center of the circle, half of it must be equal to the radius, correct? That means it is double of the radius and it is the diameter. So this particular chord, you should have a clear idea about chord, which will be touching 2 points on the circle, but it can go through the center. That means 2 points and center comes together. It becomes the diameter, and diameter is also having a definition or an explanation that it is double of radius, because this is radius. This is also equal to radius. That means from center to the circle. So 2 times radius is diameter. This you have studied. And the chord that passing through the center is also the radius. If you name all these things, the center of the circle as O, and if I mark over here OD is a radius. If I mark here B, it is OB is also a radius. If I mark A here, AB is the diameter, AB is also a chord. If I mark here P and Q, PQ is a chord. Like that we can name the chord. You can name this as D and E, then it will be D is a chord. So these all things, whatever I have explained to you now, is known to you and clear to you from previous year. But certain other properties of chord you have to understand in this video. Those properties are properties of chord of a circle first. For that we need a circle. After all, let this be the circle, and I am going to draw a chord within that. Okay, this is a chord, and let me mark the center of the circle. Let this be O. Let the chord be AB. Now we have drawn a circle, we have marked a chord within that, we have marked the center of the circle. If we draw a perpendicular from the center of the circle to the chord, that is a kind of activity which I am going to do in front of you. For that I have to draw a perpendicular. I can draw a perpendicular using a protractor. I can do it with the help of compass. I can do it with the help of set square. So let me draw a perpendicular from the center of the circle to the chord. So I will be drawing a perpendicular from the center of the circle to the chord. That is the thing to be done. Let me draw. And I will be doing it with compass for more accuracy. Let me take the compass. From the center I have to draw, so I will keep the compass at the center. Adjust the compass in such a way that I can draw arc on the, let me mark arc on this side as well as on the other side. Okay, let me take out the compass, keep it here, just expand it either on the upper side or lower. I can draw, I am doing it here. Simply keep the compass here. Okay, and you also have studied about perpendicular bisectors, almost having same technique, slightly different. The point over here is that I have taken points for drawing a perpendicular from the center of the circle to the chord. I need a ruler for drawing it. Here is a ruler. I will be just drawing till the chord because that is only required here. So this is the line joining the center of the circle to the chord. It is perpendicular, and what happens over here is the chord is divided, or it meet at a point on the chord. Let me do some measurement here so that it will become clear to you. I am taking the ruler over there for measurement. Okay, I am measuring the distance from the point at which this perpendicular is intersecting the chord. It is 2.1234 around, and on the other side also it is 2.123. That means this particular perpendicular drawn from the center of the circle to the chord divides the chord equally. It bisects the chord. Bisect means divide equally. This particular point you should keep in mind. That means here this particular distance and this distance are equal. If I write P over here, I can simply say that AP is equal to PB in its length. That means segment AP is equal to segment PP. Please keep this point in mind. This is one of the property, because we are studying about the property of chords with respect to circle, so you should keep this in mind. Okay, my dear students, let me move ahead. The perpendicular drawn from the center of a circle to its chord bisects the chord. That is a point here. Let me go ahead. Another property of chord of a circle continues. The property is that segment joining the center of a circle and midpoint of chord is perpendicular to its chord. What does it mean? What we understood is said in a different way. The segment joining the center of a circle and midpoint of the chord is perpendicular to the chord. How will we do this activity? We need to draw a circle, then we will be drawing more than one, and draw a chord in each circle. Find the midpoint of each chord, join the center of the circle and midpoint of the chord as we can as if we can measure it, and we will name the chord when the midpoint and all. Then we will check that whether they are perpendicular or not. The activity is done in the opposite way. Earlier we drew perpendicular to check that whether it bisects. Here we will mark the midpoint and draw the line to the center and check it whether it is perpendicular. I will draw it for you, one or two like that. let me draw a circle. This time I am going to draw a circle using compass, again for accuracy. This is the center of the first circle which I am going to draw. Here is a circle. I am going to draw one more circle with another radius. That becomes a separate circle then. Okay, let me mark its center, because on your paper you will get a small hole, or you can mark it and draw. Here it is like this. Okay, now I have two circles over here and I know the center of the circle. Now I am going to draw a chord each other. Anywhere I can draw, but for the convenience of showing you and drawing, I am drawing it here. One chord is drawn here. It is according to this 12.8 centimeter. This is digital scale measurement, and here I am drawing a chord for this circle also. Now what I have to do is I have to mark its midpoint. To mark the midpoint, either I can use a ruler or I can bisect it by using compass. In this case I will be using a ruler to mark it. So let me take the ruler, the scale I mean, bring it over here and measure the length of the given segment, 7 centimeter and another 0.4 division. So I will have 3.5 as its half, 3.7. Okay, I have marked 3.5, another 2 division as a midpoint of it. Here the other segment is 4.5, 4.7. So 4.8 will be 2.4. I should mark somewhere here. That is why compass is the correct way of finding out midpoint, drawing bisector. All this should be done with the help of compass. 4.8 is 2.4, almost close to it. Okay, now this is a roughly drawn diagram, not that accurate like in a paper. What we have to do is we have to draw, I have to draw perpendicular, I have to draw a line joining the center of the circle to the midpoint of the chord. That is what I am going to do. This is it. Okay, I'll be connecting these 2 points. Here it is connected. Do the same here. So the activity is telling us simply that it is perpendicular to the chord which we have drawn. So just like when a bisector is there, perpendicular bisector, it divides the chord, bisects the chord. That means the point of bisection will be midpoint, and if you know the midpoint, if you draw a line to the center, it will be automatically perpendicular. This is the point here, nothing else. Please keep this in mind. This is set square, which will help us to check whether the given line is perpendicular or not. This is a way of checking it. You can do it over here also. Bring it over here and check it. It is perpendicular. This way we say that these two lines are perpendicular to the center. So the segment joining the center of a circle and midpoint of its chord is perpendicular to the chord. This is a point that you should keep in mind. Now we will learn another property related to arc, chord and circle. For that we need all these three things first. First of all, we need a circle, we need a chord, then we will relate all these three with arc, to find out what is the connection between them. So let me draw a circle first. I will draw a circle here with the help of compass. Circle will be always correct with a compass. Okay. Suppose this is a circle, I am drawing one more circle. This is the center of it, center to be marked, otherwise we will miss the center. Okay, we have two circles on the screen. What we are trying to understand the connection between arc corresponding to the chord of a circle. So we have drawn circle, and I am going to draw two angles from the center of the circle. Two angles can be drawn from the center of the circle. For that I will be in need of let me draw it roughly, later measure it. So I am going to draw two angles. Okay. Here is an angle, one arm of the angle. I am going to draw another angle, another arm here. This angle is taken roughly, that means we'll measure it later. Again, angle is drawn, and I am going to measure the angle so that I can make one more angle of same measurement. That is the purpose. For that I need a protractor. I will take the protractor here and will find out the measure of the arc angle I have drawn. It is from 0 here, it is almost 69. So what I am going to do is drawing one more angle in the same circle, drawing one more angle in the same circle. Okay, one side is drawn, and I found that this angle is equal to almost 70. I would say like that, almost 70. So I will draw an angle equal to that here through measurement. Right, from here 0, 70 happens to be here. I will draw it here somewhere, almost 70. Adjust with my accuracy. As I told, limitation of accuracy is there in digital, but the thing is much better than before. Okay, so I have to connect that with the center. So this is another angle, and the measurement is almost 70. Almost 70 means almost 70. Now what I am going to do is I am going to mark all this. Let the center be O, if protractor sub kam ka hai, and let this be D. Let this be A, B, C, D, and for my convenience let this be X, so that XB will be an arc. Let this be Y, so that I will have CYD as another arc. Now what I am going to do is I am going to draw arc. Now I have angles here. Here is angle, here is an angle which are almost 70 degree. Now what I am going to do is I am going to draw the chords over here at the point at which these angles meet the circle. Okay, so I need to draw chords accordingly. Okay, I can draw a chord here. I have drawn. In the same way, I have to draw a chord here. I'm going to draw a chord here also. The chords are A, B and CD. Now we have to check that whether these chords are of same size. I can check it using a ruler, or I can check it using what we say the compass also. That's a method of measuring with compass. That will be more easy now. So some little bit of accuracy issue will be there, because you know that I am using a digital situation over here, digital compass over here. It must be accurate, but maneuvering is not easy. That is the problem, nothing else. The maneuvering is a tough job. So in that case, I am finding it tough to manage this. Please wait and cooperate with me. Let me see the measurement here from here also. Okay, one side is fixed. Okay, this chord and this chord which I have drawn here are of same size. From this, we need to conclude that the corresponding arc, which are the arc over here, the arcs are arc AXB and arc CYD are having chords which are equal, because the central angle is equal, or the measure of the arc is 70 degrees. So we got a conclusion out of it. We can do the opposite also. What is opposite? We'll draw the circle, we'll draw the chords, then we will measure the angle. We can do it over here. If that to be checked, we will have all those things once again. We are having center, we will have chords over here. I'll do a little fast. Here is a chord of 8 centimeter, for example, in this. Then another chord, I'll have to make 8 centimeter. Okay, then I will do one thing. I will connect this with the center. I will draw line connecting the chord to the center here, then from here to here, then from here to here, then from here to here, and I need to measure the angle created. Earlier we made the angle, then we went for measuring the size of the. Let me remove this. Okay, now I will measure the angle over here using a protractor. You should keep it properly, then only you will get correct measurement. Here the measurement starts from here. It is almost 95 little bit, and if you go to the other angle created, keep it here, adjust it properly. This baseline should be okay, center should be okay. It should start from 0, and the line is almost 95. So both these are showing the same measurement. So what we will conclude? We will conclude that, see, it is 95 plus both cases. So what we will conclude, that if you have congruent chords, here it was here it was 8 centimeter, then we got 95 degree angle here, 95 degree angle here, correct? Here we made 70 degree here, 70 degree here, and we got the length of this particular arc as 3.6 and 3.6 centimeter. See, there it is measurement. So from this we conclude that congruent arc makes congruent angles, congruent angles make congruent arc and congruent chord in the case of a chord arc circle relationship. Understood? That is a point here you should keep in mind. This equality is very important. The chords, let me remove this. The chords corresponding to congruent arcs are congruent. Chords are congruent when arcs are congruent. Arc measurement is in angle. That is the first case. Chords are congruent means arcs are congruent, then chords are congruent. In a circle, two chords are congruent, then their corresponding minor arc as well as major arc will be congruent. So these two, three things you should keep in mind. What are these 2, 3 things? Let me take you to the next screen, which will help you to remember what are those 2, 3 things. The perpendicular drawn from the center of a circle to its chord bisects the chord. The segment joining the center of a circle and midpoint of the chord is perpendicular to the chord. The chords corresponding to congruent arcs are congruent in a circle. If congruent in a circle, if two congruents are in a circle, if two chords are congruent, then their corresponding arcs are congruent. So when chords are congruent, then arcs also will be congruent, whether it is minor or major, both will be congruent. If chords are corresponding to the congruent, arcs will be always congruent. All these three important relationships you should clearly remember, so that you will be in a position to answer certain questions given in your textbook. Only 4 are given. All are direct application of the perpendicular drawn from the center bisect the arc. That is what is in exercise number 17.1. It simply deals with that, where you will be having the perpendicular bisector nature of the line drawn and the chord, and 17.2 where you will be applying the principle that the congruent arcs will be having congruent chords and congruent chords will be having congruent arcs. This particular relationship between arc, chord and circle must be applied in 17.2. As I have always said and always reminded that you should do it yourself so that you will become strong enough. I'll be putting some revision videos in order to cover up the whole textbook once again for the benefit of fixing your knowledge, or nobody is going to explain you again and again the relationship between arc, and chord in a circle, so that you should be thorough here itself. Thank you.